Minnesota land cover mapping project. Who knew that this project was happening? Okay, not bad. And who knew that Wisconsin's doing the same thing at the same time? Okay, so that's kind of cool. We've got two neighboring states both doing statewide land cover mapping at the same time. So I was asked to serve by Jim on the science advisory, what do we call it? Science advisory committee for that, and we're sharing methods, and we're going to try to make sure that the classifications are done in such a way that there's a maximum amount of collaboration and sort of crosswalk between them. So, but now we're going to talk about Minnesota, and I just want to take a second to thank everyone who helped put this together by giving me slides, so I appreciate your help. I also need to acknowledge the funding source, which is the Environment and Natural Resources Trust Fund. So we got funding via LCCMR. I won't bother to explain that. If you're familiar, you know what it is. But state funding to do this. So we're very appreciative of them for that support. Okay. Oops. Here's what we're going to cover quickly. I probably will not use the whole half an hour I was allotted, probably merciful. So we're just going to give a quick overview of land cover mapping in Minnesota, some challenges that we've had getting this work funded. It's been difficult. And then I'll talk about the current project, what we're doing and what the status is. Still a little early. We're only about 6 months in here. So we don't have anything completed, but I'll show you some interim things. Okay. So over a period of many years, the Remote Sensing Lab, RSGAL here, has done several mappings of the state and the metro and other places. So statewide collects were done in 1990 and 2000, metro only on these dates, and then Marv had a project funded by these cities to do urban tree cover mapping, but he actually did full land cover mapping as well using QuickBird imagery. There also is the national land cover data for those dates, and when I was trying to get this recent update to the statewide, we had a big gap here, obviously. Many years passed since the most recent statewide mapping. And one question I got was, why not just use NLCD? And the basic reason is that it's just not good enough for our purposes, I think. It's not specific to Minnesota. There are some significant accuracy issues if you've played around with it a little bit. We really need something that was created by us for us. And I think Jim would probably agree that Wisconsin would be in the same situation. So I'll show you, this next slide is the 2000 mapping. Excuse me. This is a pixel-based classification, so each individual pixel, as you know, is assigned a land cover class. Pretty good classification. I don't remember the number off the top of my head, but high 80s, Marv, would that be accurate? Yes. Yeah. So we just recently, Marv got a project funded by the Met Council to repeat mapping for the metro only. This is based on 2011 data. This one was based on an object-based classification approach, which I'll describe in a minute if you're not familiar, with LiDAR imagery, or LiDAR data as one of the important data sources. And this one is 91% accurate at both the level 1 and level 2 classification levels of detail. To contrast those two, this is a blow-up of an area, this is Woodbury, not too far from where we are. Maybe we're even on there, I haven't looked, but so this would be the expanding, urbanizing core of Woodbury, and this is agriculture land. Sorry there's no legend on there, but it's similar to this one, so if you can maybe remember the colors. Looks okay, right? You can see some speckle. Not quite nice, crisp boundaries on things, but then you move to the object-based classification for 2011, much better, nice, crisper, cleaner, looks better, not only looks better, but it's more accurate. So we're pretty happy with that. I'll show you this. The object-based classification works, and again, I'll explain how that works in a minute. Here's the urban, Leif Olmensen did most of the mapping work for this, by the way, so he deserves credit for that. We also, Marv actually, didn't have anything to do with this one, mapped St. Paul, Minneapolis, and Woodbury urban tree cover, and those are right here the 3 cities. Minneapolis and St. Paul were done with the help of LiDAR data, but there was no LiDAR for Woodbury, so it was done separately. But even so, these classifications are very, very good. 91, I believe, in that area, % accurate. So we feel pretty confident that the combination of LiDAR and object-based mapping is the way to go. So you might say, well, why can't we just do this? Why does it have to be 15 years or more between mappings for the state? It's important. It's something that people use. We get lots of hits on the website downloading this data. And what it really comes down to, as with everything in life, is money. It's been quite a challenge getting this funded. Well, I'll show you. We'll show you that slide. So federal agencies, with all the great things that they do, they're not really all that interested in mapping Minnesota. Right? So we can't go to the National Science Foundation and say, hey, fund us to map Minnesota. They don't care. That's not part of their purview. And Fish and Wildlife as well. That's not really their deal to map Minnesota. So we really have to use state sources. The problem, though, is that state agencies don't typically have big pots of money that they can put towards something like this. The skills that are required to do this mapping are substantial, and that means that the people are not cheap to keep around. So it's an expensive endeavor, and state agencies typically don't have, as I said, lots of money. It would be better if we had some kind of consortium where everybody puts in a little, and then there's continued funding, which I suggested at the State Geospatial Advisory Council meeting last year. One of their meetings was not met with resounding success, I guess. I suggested it, but they didn't seem all that interested. So what we've been doing is cobbling together funding from multiple places, state agencies where we can get it, but this most recent one is LCCMR, Legislative Citizen Commission on Minnesota Resources, I believe. The problem, though, is that it's a difficult way to get funding. It's very political. It involves a lot of lobbying. I spent a lot of time on the phone with commission members trying to help tell them why this is important and why they needed to support it. It's not like your standard proposal review process where you submit a proposal and it's evaluated based on its merits. It's much more who you know and how effectively you can communicate the importance of your project. And we were told, after getting funded this most recent time, not told directly, but strongly hinted that LCCMR would not fund this again. That could always change, but they said, look, this is probably the last time you're going to get money for mapping out of us. So we don't know what to do for future collects, right? We're going to need to do this again. We'd rather not wait 15 years. So we'll see. Important stuff. We'll see if we can continue to do it. Questions so far? How are we doing? Anybody got a couple $100,000 laying around they want to put toward the next map? Not so much.
Kickstarter?
Kickstarter? That's actually a good idea. Yeah, put it up. Okay. What? Oh, I'm sorry.
No, I'm sorry.
So how are we doing the new project? As you can probably imagine, we're using object-based classification on LiDAR. Right? Statewide, we now have the statewide LiDAR data collect. I don't need to tell you guys that, how important it is and how much of an impact it's having statewide. Really great stuff. And we are using object-based classification, and we're dividing the state up into ecoregions and processing each ecoregion separately. So Minnesota has a tremendous amount of variability from north to south and from east to west even. And so we didn't think we could come up with one approach that would classify the entire state in one go. So we're chopping it up, and I'll show you how that happened in a minute. But probably the core data set here is LiDAR. This is a shot of the capital area. Everybody has seen this, I'm sure, this kind of thing. This is the Minnesota statewide LiDAR, full point cloud, and nothing else. There's no satellite image under this. That's just LiDAR. And people never believe that when I tell them, but it's really true. Like this is LiDAR intensity and point cloud. Really high quality stuff. Optical in the same area. So it almost looks like a real, this one particularly, digital surface model, right? I mean, that's not too far off the actual image, and there's no optical there at all, except for LiDAR intensity. So we can derive DSM, DEM, etc. And cool things like looking at the number of returns in a given, this is messy, but it's the number of returns in a given, for a given pulse. So something that just returns once, hit something hard and bounce back one time, top of the building, road, etc. Whereas multiple returns means it encountered typically vegetation. So we can look at plot the return numbers from the side and start to see those kinds of cool patterns come out. This stuff's incredibly powerful. Not only this, we can derive interesting things from it, other products. So I'm not going to go through all these, but again, DEM, DSM, terrain models, compound topographic index, all kinds of different indices just from LiDAR to augment the satellite imagery that we're using. Okay. Yeah, Pete.
Yeah, a question for you. Because the LiDAR collect was done in various regional collects, do you notice some discrepancy between various parts of the state in terms of how your object base worked with those various LiDAR collects?
When you say discrepancy,
I mean, you know, in some cases they did a certain level of classification, and in other areas they did a lesser level of classification. You know, where vegetation was classified as vegetation, whereas some was high and low,
right,
and some was high, medium, and low?
We are not using those values.
Okay.
We're using the full point cloud and driving everything but building footprints ourselves.
Okay.
So we're not using any of those.
How about some of that differences in ground sample spacing?
Yeah, that's a problem.
Okay.
Leon's done some interesting work on how the sampling intensity affects building footprints and things like that, and it does affect it.
Because the metro area there was some areas like Minneapolis, St. Paul had so many points per square meter, and other areas had much less, and then there were certain other areas that had them, you know, 1 for 1.8 square meters. You know,
more or less.
Yeah. So
it's a problem, but there isn't anything we can do about it. We're just going to have to develop methods.
But it's usually, is it uniform enough over a large enough area that you can? Okay.
Yeah,
okay.
sure. Yeah. Typically, individual counties bought up, right? So you'd be mapping on a county basis.
Correct. Yep.
Yeah.
Yeah.
Other questions? Happy to be real casual here, so if you want to interrupt, go for it. Okay. So who would say they have a good working knowledge of object-based classification? Great. I was hoping that there wouldn't be. So most of you don't. So if those of you who do understand it, if you'll indulge me for a few minutes here, I'll describe to those who maybe are not so familiar. Okay. Don't say anything. I'm going to put a slide up. Just be quiet and think. Okay, you can say something now. What do you see? Keith, you can't respond to this. Does anybody not see horses yet? Still? It usually takes a little while, right? Yeah. So how many? 4?
No. Is there more?
More?
I'm hearing lots of different numbers. Well, how did you?
Oh, I think there is 5.
There's 5?
5. How did you do that? How did you do that? How could you see horses in this thing? What would a pixel-based classifier do with this image? How many classes would you get out? 2 or 3, right? You'll probably have a brownish class and a whitish class and maybe a blackish class from the tails and things and shadows in the rocks, right? It would be a disaster. With a pixel-based classifier, you're not going to be able to identify horses, but you did that because you can see the patterns that are inherent in the image. Okay? Same kind of thing with this. We all know what that is without having to think about it, right? Subdivision. We all know what this is without having to think about it. And this. Yeah. So the idea with object-based classification is you try to approximate what your brain is doing in software. So our brains use these things, the elements of image interpretation. Yeah, we've all seen those before. And what you're trying to do is to teach software how to use these things that we do intuitively. And this is very brief. I can go into more detail with you if you like. But we call it a knowledge-based workflow. And the first step is to identify objects. So homogeneous elements of the image. So things that are the same. A road, or a building, or a woodlot, something like that. Something that looks relatively homogeneous. That's called segmentation. That's the first step. You identify those homogeneous blocks. And then there's this iterative process whereby you refine the segments through looking at things like relationships between objects, size, shape, all these various parameters that you can pull out. And it's a very iterative process where you're changing polygon boundaries, refining the segmentation, changing classification values based on looking at all these things kind of holistically. And that's a really wordy description of maybe nothing, but the idea is that you think about the process that you use when you look at the image to identify things, and then develop rules to teach the software how to do that same thing. Here's an example. This is a Worldview 2 image from Ridgefield. Now we can identify buildings because they look rectangular or perhaps circular. Roads are long and thin. What is that? Okay. Roads are long and thin. Trees are kind of irregular and bushy, right?
Take the toys away from
He's always screwing around with that thing during lab meetings. So let's look at some objects, right? So from some of the classes we can derive objects. I don't have wall-to-wall objects on here, but you can see things like, hopefully you can see these in blue, around the buildings, around the trees, etc. So each one of those objects has parameters associated with it. And these might be, this is a partial list of those. So what are the spectral values? What color is it? How big is it? What is the shape? Is it long and thin, or is it round, etc.? How consistent are the spectral values? What is the texture? All these various things. What are its relationships to things near it, right? If you see something that looks kind of cross-shaped, and it always occurs near a long, thin thing, maybe that's an airplane, right? So these kinds of relationships are surprisingly powerful to pull out land cover classes. And the idea is, how do you use all of these various pieces of information that you have about objects to hopefully uniquely identify land cover classes? Contrast this with pixel-based classification. What do we know about pixels? We know the spectral values. We might know how the pixel relates to its neighbors. But we don't know anything about shape or structure. Right? That's not something that's easy to pull out from pixels. But in the object context, we have all this extra information, and that can be put into various kinds of models to derive classification results. Okay? A lot in a short period of time. Questions? Cool. So what did we do in the statewide? We use this in the state. We're using this in the statewide mapping. I mentioned, first of all, that we're segmenting the state into ecoregions. You're not going to be able to read these ecoregion names. It's way too small. But these are the ecoregions that we are chopping the state up into. We have only two, unfortunately, statewide mosaics, summer and fall, 13 and 14. Really cloudy, unfortunately, so we weren't able to come up with full statewide spring or any other full statewide dates, just bad luck. But we think 2 is probably enough, right? The contrast between the growing season and not is going to be useful. And here's a blow up of the metro. And from these, we can derive things like NDEI, etc. All right, no surprise. And also from the LiDAR, various kinds of indices and models. Probably none of these are a surprise to you. We're also using ancillary information, some of these. So for example, with roads, and I should also give credit to Leon, who's doing the mapping work on this. So she's put most of these slides together for me just today. So we're using roads, a roads layer to identify objects that we think are roads. We're the same with city streets, airport runways. And then we're incorporating, where it's available, we're incorporating the new NWI layer. For now, 13 county metro, and soon the southern 40 counties of the state. But the NWI will not be complete by the time the statewide mapping is done, unfortunately. So we won't be able to include NWI statewide.
Question?
Yes.
So the LiDAR is from quite a few years before the Landsat?
Quite a few, 3, 4.
Okay.
Yeah.
Okay.
Yeah, things change. I mean, the one big thing that's changed is the green line.
Oh,
It wasn't there when it wasn't much there when the LiDAR was acquired, and now it's. So yeah, unfortunately, things change. And wouldn't it be nice if we could get new statewide LiDAR every 5 years, right? Tough. So we're using all this optical LiDAR ancillary data in an object-based analysis sort of structure. This is in eCognition. It's the software that we're using, which every time I see it, I like it more. I mean, my goodness, fantastic software. Super expensive, but it's very powerful. Amazingly good results, I think. And I don't use that word lightly either. So again, the first step is segmentation. Identify things that are homogeneous. This is an object. And then we're using the ancillary information I put easy in quotes. There's nothing that's really easy about this, but use the ancillary information to classify things that are relatively easy. Roads, streets, etc. And then the things that do not get captured with the easy part of the rule set, we're putting into the random forest classifier. Who's heard or familiar with random forest? Again, real quick overview here. Random forest is an ensemble classifier. So what we're doing is we're taking all the information that we're deriving from optical, from LiDAR, from ancillary, LiDAR-derived metrics, etc., and putting it into this classification. So you have a whole bunch of input layers and a whole bunch of training sites. Put that into the model, and it does a supervised classification and assigns things to your output classes. So just very briefly, what it does is it'll take a random assortment of the input variables, optical, DSM, etc., whatever, random assortment of the input variables and a random assortment of the training sites, and try to build a tree with those. Then it pulls another random assortment of training and random assortment of layers, builds another tree with those. And it'll do that hundreds or perhaps even thousands of times if you want it to, until you have a forest of trees. Okay? All of them with slightly different combinations of input data and training information. Then you start running your pixels, your unknown or objects through the tree. Every tree through the forest, every tree gets a vote, and the class that has the most votes wins, right? Now, if you sit and think about that for a while, it's completely illogical, right? How would a random assortment of data ever lead to something that works well, right? It doesn't make any sense. Wouldn't you want to pick the one optimal set of data and training? No. The theory is that this ensemble classifier magically makes all that go away when you have hundreds, thousands of trees, right? And it's been proven to be robust with this kind of approach, so we feel like we can trust it. Wisconsin is using support vector machines, which we're also going to evaluate in this. I don't really have much experience with those other than knowing the theory, but we're going to see how those perform as well. Yeah?
Did you try the CART classifier and see the effectiveness of random forest versus CART?
Okay, so CART, you can imagine that random forest is a whole bunch of carts. Okay, so CART is a tree-based classifier, and random forest is somewhat like an ensemble of carts. Okay, so we feel like using one CART would be limiting compared to using thousands of trees in a forest. Does that make sense?
Well, to some extent.
Afterward, we'll talk more detail.
Okay.
Okay. I didn't convince you. Other questions? All right. So, what does it look like? Here's our preliminary map. So this is a part of this is St. Paul. Let's see. Pretty darn good. This is a first cut. This is hot off the presses as of yesterday, right, Liam? So has not been subjected to rigorous review. This is the first cut. And it looks pretty darn good. We're very happy with the first iteration through. I don't have accuracy numbers yet to tell you because of the way we developed the map. We haven't done a comprehensive assessment yet. And this is only level 1, right? So we're not showing you forest types. But really happy with the results so far. I need some tweaking, of course. Things have to be improved. But so far, good. That's your only teaser slide there. That's all you get to see. So a question, though. I keep talking about object-based classification. Do you think we always want to use object-based classification? Just use it for everything? Or if not, what might you not want to use object-based for?
Weather data.
Weather data. How do you mean?
Why would I want to see a cloud? I'm looking at moving features that are changing.
Okay.
By an hour by hour.
Good.
Can you repeat what he said?
Yeah, sorry. Don't use it for weather data because you're not so much interested in a cloud, it's how the clouds are moving. Is that accurately? Okay. Yeah. What do you think? Others? Where would a pixel-based classifier maybe be better or at least give you different information?
Things that change gradually, like soil types. Maybe?
Things that change gradually. Okay, yeah. So if you have inconsistent object boundaries,
Yeah, things that
maybe we
have
don't. Okay,
Good edges.
sure. And kind of related to that, another one that I hear a lot is when you're operating at multiple scales. So if whatever phenomenon you're measuring is happening at widely varying scales, objects may not make sense in that case. Okay. But in the context of this project, one thing that we're not doing with objects is impervious surface mapping. So this is going to be done on a pixel by pixel basis, and this is I don't want to get into the details of this, but basically uses tasseled cap to estimate greenness in each pixel, and then so we're going to superimpose pixel by pixel impervious percent estimates on top of the statewide product. So this is useful, as you can imagine, for a variety of things: stormwater, flow modeling, etc. Okay. Another one, I guess, would be Marv and Leaf's voluminous lake water clarity work. Those are pixel-based estimates that are often generalized to lake boundaries, but still, it's nice to have that pixel-wise depiction of how clarity changes within a lake. Okay, last slide.
Oh, I have a question.
Yeah.
For your impervious surface, are you masking out areas ahead of time before you do the impervious surfaces, or like are you just putting a square around like you have there? I don't even know what is that St. Paul.
Yeah.
Anyways, are you just?
So okay, let me answer your question. So we don't care about impervious in places that aren't urban, right? Well, I don't. So the first cut of the classification is to identify all of the sort of level 1 classes: forest, urban, water, right? And then only for the areas that are urban are we going to project impervious surface percent.
Okay.
Others? Okay, last slide. So this works. I hope I've made the case. We're really happy with the integration of object-based and LiDAR. I should also mention again that the Wisconsin classification is going to use objects. They're going to use it in kind of the reverse way that we are. We're starting with objects, and they're going to take the pixel-based class. Correct me if I'm wrong, Jim. Take the correct pixel-based classification and then generalize that to objects on the back end, which is interesting, perfectly valid way to do it as well. And I would say I'm optimistic that we're going to produce a high-quality project which will make Goldie smile. Right. Any questions?
What's your detail?
Pardon me?
What's your detail, like in forest land?
Minimum mapping unit, or?
No. What's your detail, different cover types?
Oh, level.
Just forest, or?
No. At minimum, it'll be evergreen, coniferous deciduous and mixed, something like that. I'm not confident that we can do speciation.
Okay.
There'll also be a wetland class, so if you're interested in upland versus wetland forest, those will be mapped.
You're not going to pull that out of the national wetlands inventory?
We will if we can get it.
Oh, okay.
Yeah, that's the thing there. So if you guys don't know, The 40 counties, if you draw a line through the Twin Cities and then go south, the 40 counties in that part of the state will be done soon, right? Within months, a couple months. Ducks Unlimited is working on mapping the forested portion of the state, you could say the Arrowhead, right now, and that's a little ways off, and probably will not be ready in time to drop into this presentation.
I'm just wondering about the scale parameters. Are you looking at different scale parameters vis-a-vis the ecoregions, or do you have just one harmonious scale parameter to?
Yeah, it's going to vary, I think. We have not answered those questions yet. If you want numbers and things, talk to Leah. She's the. But yeah, it'll vary. It'll vary depending on ecoregion, I'm sure. Somebody else.
So for the impervious-based surface mapping, would you get a good enough resolution to look at an urban area and determine areas that would be higher risk for flash flooding because certain areas are just total concrete jungles and other areas less such?
Without having experience in doing that kind of thing, I would say probably yes. I mean, we're talking about 30-meter pixels.
Okay.
And Marv has done this impervious mapping procedure a number of times, and it works really well. Really impressive results. So I think yes, qualified yes.
Right.
Yeah.
Just curious, what are you going to be doing as far as the validation? Are you going to be comparing it to other land cover data sets over the state, like NLCD, CCAP, or I guess are you going to send out students to go out and do validation? I'm just curious.
Yeah. I don't know that it would be all that useful in terms of validation to compare with NLCD and CCAP because frankly we're going to do better. Why would we compare with something that's not as good, right? Well, and I'm sorry.
No. You're right though. I mean, like the CCAP data, I mean, we do break out the wetlands into multiple classes and the forest into multiple classes.
Yeah.
And of course, USGS goes and aggregates it back up.
Yeah.
I was just curious, what is your validation?
Field and image based. So we've got 5,000 or 6,000 points around the state right now, and we'll be collecting some more. Summer of 16, I guess, which will be toward the end of the project. But yeah, field based, and then there'll be several thousand probably image based as well.
Are you doing high resolution stuff?
Yes, right. Yeah, I was talking about statewide, but yeah, we are. Thank you. We part of the project is to do high res for a few selected areas, so that'll be based on commercial imagery. I don't have anything to talk about with respect to that, though.
Will you be making your mosaics available?
Sure.
Next meeting, the last one? Yeah.
Others? I did use my full half an hour.
And you don't.